The last package that we will introduce in this video series is the Commodo/field storage ref, and it's a package that just exports a single field called ref that you can use with the Fields higher order function. The ref field is essentially an extension to the Commodo/field storage package, and it enables us to represent traditional one-to-one, one-to-many, many-to-one, and many-to-many relationships between different entities in our app. You will probably want to use this field with more relational databases like, for example, MySQL, and even with some NoSQL databases like MongoDB. But if you're going the full NoSQL path, where, for example, data denormalization isn't an issue, you actually might not need it, and could probably get away with all of the default fields that the Commodo/field storage package provides out of the box. But let's take a look at some of the code samples and see how it works. In front of us, we have simple book and author models, both having the with storage higher order function applied, which means both will be storing data to the database. Having the with storage function applied on all related models is also required by the ref field. Also note that the title and nickname fields have a simple validation callback function assigned, making them required fields. The next step, of course, is to create an instance of each model and try to save them. First, we will create a new book model instance, which we then assign to the author model instance, and finally we call the save method on it. A couple of things to note here. First, notice that we didn't call the save method on the book1 instance. It's not needed because the ref field is smart enough to be able to handle it for us. It will call the save method on the model instance that was assigned when needed. Next, there are three types of values that the ref field can accept. In the example we've seen, we assigned a simple book model instance, and this is probably the most straightforward way of assigning values to a ref field. But except a model instance, the ref field can also accept a plain object with data, like this. In this case, behind the scenes, the ref field will create a new instance of the model provided in the instance of field argument, and simply populate it with received data. And finally, the ref field can also accept a simple string value representing the ID of the database entry we're trying to reference. In that case, upon value assignment, the ref field will ensure that the provided ID is valid and that the entry exists by simply calling the findById on the provided model. If the ID is invalid or the entry wasn't found, an error will be thrown. Let's undo this change so the error goes away. Now that we saved the author with the book2 ID, we should be able to get the book's title via the favorite book field, like so. Which brings us to the next point, and it's related to ref Fields Asynchronicity and how it is loading data. Notice the a bit clunky way of fetching the title of the author's favorite book here. This is because the ref field is asynchronous, meaning when we want to access the value of the field, we need to use the await keyword in order to wait for the promise that is returned from the field to be resolved. That is the only usage-related difference when compared to other fields. In order to make this a bit nicer, we can first just assign the favorite book to a separate favorite book constant, and then access the title property from it, like so. Also note that the data is always lazy loaded, meaning the ref field will try to avoid fetching the data from the database as much as possible. For example, database calls are only happening when the field is actually accessed. Also, when assigning a new value, for example a simple string ID, the mentioned findById call on the provided model won't be performed until the base instance is saved. These are some of the examples, but there are many more optimization measures inside of the field which we don't have to worry about at this point. And finally, when it comes to checking, a couple of words on the data validation also. In our previous video, where we covered the with storage higher order function, we mentioned that the data validation is automatically triggered and will prevent the actual save if the data that was assigned to the model instance is invalid. And it's not any different here. If we, for example, remove the author's nickname here, an appropriate validation message will be thrown, saying an author must have a nickname. And also, having invalid data on a model instance that was assigned to the ref field will also cause the save to be prevented. So, if we remove the title on the book2 instance, we would again see an error in the console, this time saying a book must have a title. So, the whole save will be prevented, not just the save of the book2 instance. The examples we've seen are basically demoing the many-to-one relationship, or in other words, we have many authors that can be linked with the same book. Note that when we delete the author model, the book instances won't get automatically deleted, and you'd need to delete it yourself if that's the expected behavior. But what you can also do is set the auto-delete field argument to true like so. This flag will make sure that the linked model instance is always deleted once it's unlinked from the base model. So no matter if the base model is deleted or we just assigned a new value to the base model's ref field, the linked model will be deleted. Although this might not make much sense in this particular case, note that this addition essentially turns this existing many-to-one relationship into a one-to-one relationship. An example where this might actually make sense might be a user model, which has the verification document ref field. Since only one document can be assigned to the user and belongs only to him, we might decide that deleting the user should also delete the document. If you end up in a situation similar to this, then having the auto-delete set to true can definitely be considered as a good choice. Let's quickly see this in action. So here we're going to delete the author model. After doing that, by doing a direct find on the book collection, we should not have any entries in it because of the auto-delete equals true that we just applied. Note that both book database entries are missing because the book 1 was deleted once we assigned the book 2, and book 2 was deleted once we've deleted the base author model instance. And if we would undo this auto-delete equals true field argument, we would see that both book entries would still exist in the database. And with that, we've covered the essential concepts of the ref field. With the shown many-to-many and one-to-one, the ref field can also be used to represent a one-to-many and many-to-many relationships, which we are about to see in the following video. To sum up, we've seen how we can use the ref field in order to represent a many-to-many relationship, and at the very end, with the auto-delete field argument set to true, even a one-to-one relationship. The field can accept different values, an instance of a model set via the instance of field argument, a plain object, and a simple string that represents an ID of an entry in the database. The field is asynchronous in nature, or in other words, it always returns a promise, which means we always have to access it via the await keyword. And finally, before the model is saved into the database, data validation will not occur just on the main model instance, but on the referenced one as well.